an unidentified object collided with the James Webb Space Telescope. When astronomers first observed a peculiar cigar-shaped object rushing past the Sun, they could infer from its course that it had come from another star system, but they didn't know exactly what it was. Omumua is the first known interstellar object identified traveling through the solar system. Researchers created ripples in the mainstream media after publishing a report stating the item may have had an artificial origin, offering hypothesis that Omumua could have been delivered purposely to Earth's vicinity by an alien culture. This theory is based on the object's excess acceleration or its unexpected rise in speed distinct from the Sun's gravitational impact. This still confuses researchers. A new study published lately in the journal Nature suggests that the interstellar visitor called Omumua is neither an asteroid nor an alien spaceship, but a small interstellar comet. Comets are cold, dusty objects that have been related to filthy snowballs frequently produce lengthy tails when they come close to the Sun. No such narrative was seen in earlier observations of Omumua, which means scout in Hawaiian, which helped other astronomers think it was an asteroid. Still, ground-based observatories and the Hubble Satellite Telescope's investigation of new data yielded a surprise. Omaha's trajectory couldn't be explained only by the Sun and the planet's gravitational forces imposed on it, as would be the situation if it were an asteroid or a space rock. The team tasked with the study decided that the unexpected motion of Omumua had to be caused by the spewing of minute quantities of gaseous components from its surface. Once they recognized that Omumua was not slowing down as fast as should have been under gravity forces alone. This outgassing typically seen in comets was too little to be visible, but significant enough to impact MAMA's course. However, not everyone is buying that theory, at least not totally. An astronomer at the University of Toronto, Scarborough, told Mac in an email that Omumua must have lost much of its ice before it left its parent star system, if it is a comet. Omumua, he added, appears to be somewhere in the uncertain area between a comet and an asteroid because of the amount of ice it has shed. However, Jackson was not part of the recent study on Omaha, which may be just the first of many interstellar visitors that we may see in the future. The new James Webb Space Telescopes, according to Jackson, could make it easier for astronomers to find more things like Omaha, which will allow us to develop a complete picture of how planets form in other planetary systems. At around 70,000 miles per hour, a woman is currently en route to the outer solar system. Astronomers have used the Atacama Big Millimeter Submillimeter Array ALMA to understand the asteroid Psyche's composition better. In 2026, NASA will send a spacecraft to investigate an asteroid between 179.5 and 329 million kilometers away from Earth. The most recent studies indicate that its surface is rocky and highly metallic. Annibale di Gasperi, an Italian astronomer, discovered Psyche in 1852. Because it is a giant asteroid, yet found, this one is classified as an M-type asteroid with an iron meteorite-like spectrum. Psyche's thermal emissions observed by asteroids could provide more information about the asteroid's composition. Thermal inertia, or the amount of heat radiated from the surface during the day and at night, can be inferred from the amount of heat emitted. Catherine DeClaire, an assistant professor at the California Institute of Technology, who is the first author of a paper detailing these new findings, says thus: infrared investigations of the asteroid's surface using ground-based infrared detectors are difficult due to Psyche's small size and distance from Earth. In the past, only single-pixel images have been produced. To solve this problem, DeClaire and her colleagues used data from the ALMA facility in Chile, which consists of 66 radio telescopes. It's possible to see the Psyche's surface several times a day by keeping an eye on it. Its thermal inertia was better understood by making 50-pixel pictures. Psyche's composition isn't homogeneous, as evidenced by these fresh photos taken by the ALMA probe. In comparison to other asteroids, the thermal inertia of Psyche was determined to be relatively high. a high inertia item radiates 60 fewer degrees of heat than expected. This may be because the asteroid's surface is at least 30% metal. On the other hand, a metal surface has an unpolarized light bouncing off of it, which is not the case with a metallic item. Since metallic granules are found throughout its surface material, they think they are responsible for scattering light. It is possible that Psyche is a pre-planet with a core, mantle, and crust before it collided with another object, or that it is a planet that was formed after a significant collision with another object. According to the researchers, an abundance of instantite chondrite on the surface of Psyche could indicate that the asteroid developed in a separate region of the solar system from the material being accreted closer to the sun's surface. Asteroid M-type thermal emissions were observed and mapped for the first time with superb spatial resolution. However, only a few micron observations of rocky and metallic asteroids can be used to determine their composition more than a few millimeters below the surface. In August 2022, multiple payloads from the Psyche mission will be sent inside the asteroid to investigate its composition further and establish whether it is a core fragment of unmelted material. Declare expects that future observation, whether from Earth or the Psyche mission, will be able to distinguish between the two alternatives, which both remain viable for the time being. The James Webb Telescope's specification. The Hubble Space Telescope was the most innovative astronomical observatory when it was developed and designed by scientists. The fact that stars and galaxies had formed within a few 100 million years after the Big Bang was one of many unknowns about the cosmos. To get those early stars and galaxies that had lit up the universe after hundreds of millions of years of darkness following the Big Bang, it became clear that another even greater space observatory would be needed. These early stars and galaxies, located more than 13 billion light-years away, needed infrared detectors to catch the feeble light. Certain early galaxies radiate visible light. However, their distance means that the redshift macrophane causes these galaxies to emit infrared radiation, which Hubble was designed to detect. Scientists in Edinburgh, Scotland, were the first to construct infrared detectors, including a PhD student. The combination of this technology is the James Webb Space Telescope's forward cutting-edge scientific equipment. It is hoped that the four state-of-the-art detectors will be fed light from the nearby and distant universes by the James Webb Space Telescope's huge mirror. Spectroscopy, a method that examines how stuff in the cosmos absorbs light, is used. Astronomers will be now able to discover what the stars, nebulas, galaxies, and planets in the James Webb Space Telescope site are comprised of, since various chemical elements absorb light at different wavelengths. While the Hubble and Webb telescopes are frequently compared, their photographs will show different elements of the universe. Because of its infrared capabilities, Webb's telescope will be able to peer through the dust into the center of nebulas, galaxies, and star-forming areas that are otherwise inaccessible to Hubble's vision. Because of the James Webb Space Telescope, astronomers have been able to study star formation in our galaxy. Let us know what you think by leaving a comment below.